The compressor. This may be centrifugal or axial flow. The point of having a compressor is that it provides an increased mass flow of air, better combustion characteristics, increased efficiency and thrust, improved fuel economy, and can fit in small, compact engines. Compressors increase energy level of air received from the intake, compress the air and discharge it to the combustion chamber. Work done on the air uses power extracted by the turbine. Compression is adiabatic. After air has passed through the compressor, the temperature will be higher than the inlet temperature. Here's a centrifugal compressor. It's two-stage. It was on the Vickers Viscount turboprop aircraft. It's exhibited at Cranfield University. It's the Rolls-Royce Dart and became the world's first gas turbine engine to be used for scheduled passenger service. Here's the Rolls-Royce Gem, also another exhibit at Cranfield University. 3-shaft engine configuration, a reverse flow combustor featured in it, and is used on Westland and Lynx helicopters. Compressor surge. Compressor surge is when forward flow through the compressor can no longer be maintained due to an increase in pressure across the compressor and a transient flow reversal occurs. Severe compressor stall can be indicated by a rise in turbine gas temperature and an increase in vibration levels. Rotors and stators. As the rotor turns, airflow is induced into the compressor. The airflow angle of entry to the compressor is adjusted to provide optimum performance by the inlet guide vanes, and the airflow is accelerated rearwards by the first stage rotor blades into the first stage stator blades. The rotor blades impart a velocity and pressure rise to the airflow, and the stator blades decrease the velocity, increase the pressure, and deflect the airflow to the correct angle for the next stage rotor blades. The blades, both rotor and stator, form divergent ducts. So as we go through the engine, we'll see an increase in pressure and an increase in velocity, and a decrease in velocity but a continuing increase in pressure, and so on, with the pressure increasing as the air flows through each of the rotor stator vanes of the compressor. The centrifugal compressor components include an impeller, which can be single or double-sided. This imparts kinetic energy to the airflow and the pressure increases. And a diffuser, which has divergent passages where airflow velocity decreases and pressure increases before air passes to the combustion chamber. And then there's a casing to house the impeller and diffuser. There's a high pressure ratio of approximately 4:1 per stage. It's a very large diameter. It's used in small engines such as the Pratt & Whitney PT6. The advantages are simple to design, easy to manufacture, less susceptible to surge stall than the axial flow compressor. However, there can be flow losses due to many tight bends. The axial compressor. Below its design speed, an axial compressor has a tendency to surge in the front stages. Compressor bleed valves are used to prevent surging at low compressor RPM and reduce the likelihood of compressor stall. There's a lower pressure ratio per stage, with an ability to compress a large mass airflow. However, they are expensive to manufacture.